Okay, 6.5, we're going to talk about integration by substitution. So we're going to learn a new way to integrate. So here we have an anti-differentiation of composite function. So we're going to be given a function either that's going to be like in parentheses or under a square root that we can't use our typical integration strategies to find the antiderivative. So we're going to use a new strategy. So we're going to use substitution. So we're going to let u be whatever our inside variable is, which this will make sense when we start to do examples. It's a little bit funky from here, but once we start to do it, you'll see it a little bit better. Then we have to say du, because if we substitute a u into the x's, we're going to have to substitute du for our dx, is going to be the derivative of whatever the inside is. So we're going to use substitution, we're going to plug u's in, and then take our antiderivative. So we haven't seen example 1 yet, but it says example 1 shows how to apply 6.13 directly by recognizing the presence of our function, so our composite function and the derivative. Note that the composite function in the integrand has an outside function f and an inside function g. So the derivative g of x is present as a factor in the integrand. So we'll see this when we start to do examples. So looking at example 1, I'm going to use substitution. I'm going to say let u be the inside function here. So x squared plus 1. Which means du is going to be the derivative of u. So what's the derivative of x squared plus 1? 2x, perfect. 2x dx. Don't forget that dx. So from here, we're going to substitute our u and our du into our integral. So we have the integral of, I'm going to plug u into my x squared plus 1, so I have u squared. And then 2x dx, bless you, 2x dx we said is equal to du. So I'm going to substitute du into that. Now from here, we can take our antiderivative, our integral. So when I take the antiderivative, what would we get? So it'll be u cubed, right? Times 1/3, or over 3. Yes. What am I missing? So if I take the antiderivative, what do I need to include? Plus c, awesome. So last step is we want to substitute the x's back in. So I'm going to take what u is equal to, and I'm going to plug that into the u. So we have 1/3 times x squared plus 1 cubed plus c. So this would be our antiderivative. If we took the derivative of this, you would end up with the original question. So you can always check your work by taking the derivative of your answer. All right, let's look at b. So we're going to let u be our inside function. So let u equal 5x plus 1. So then du would have to equal the derivative of it. What's the derivative of 5x plus 1? 5 dx. So now we're going to substitute our u's in. So 5x plus 1 is u. So I have the square root of u. And then 5 dx is just du. So I'm taking the integral of the square root of u times du. We like to write this a little bit different to help us with our antiderivative. So I'm going to call this u to the 1/2 power du. What would our antiderivative be here? Awesome. U to the 3/2 power. we would say over 3 over 2, but when we simplify that, it'd be times 2/3. And we keep change flip. Plus C, perfect. I gotta do one more step. I can't leave the U in my answer. I gotta substitute the X back in. So I'm gonna take what U is equal to, plug it back into the U. So we have 2/3, 5x plus 1 to the 3/2 power plus C. So that would be our answer. So let's look at example 2. I'm gonna say, let U equal the inside. So U is gonna be x squared plus 1. What's the derivative of U, or the derivative of x squared plus 1? 2x, awesome. Dx, don't forget the dx. Thank you. So now when I substitute in, I'm gonna substitute the U into my x squared plus 1. And I'm gonna substitute the du into the, I need a 2x dx, but I only have an x dx. So what I could do is I could put a 2 in there, but I also have to put a 1/2 in there too. So I'm gonna multiply the outside by 1/2. Because when we're taking the integral, it doesn't matter if our constant is inside or outside. So if I'm gonna multiply by a 2 on the inside, I have to multiply by 1/2 on the outside, because this would still just be 1. So now I have a 2x dx that I can substitute the du into. Does this answer your question, Kevin? So if it doesn't look exactly the same as our derivative, we can make it look the same. So now I have the integral from u squared, or the integral of u squared du, because that 2x dx got substituted, the du got substituted into the 2x dx, but I'm still multiplying this by 1/2. So the 1/2 has to stay on the outside. All right, so on Friday when we started the notes for 6.5, we found what u should equal, which is typically our inside term, and then du is just the derivative of that. Example 4, you'll kind of see once we started, it doesn't match up exactly to where when we substitute, we can substitute in our u and du. So let's take a look. We are going to say that u is equal to what? So u is going to be the inside, so 2x minus 1. What's du equal to then? What's the derivative of u? The derivative, so 2 dx. So if we substitute in, we have our integral. I don't have anything that I'm plugging into x. I can say, I could put a 2 here and a 1/2 outside, so that way I have 2 and dx that I would plug du into, and then I could plug in u into the square root. So I have x times the square root of u du with the 1/2 outside, bless you. But I can't take the derivative of this because I still have that x in there. So what I need to do is find what x equals in terms of u. So I want to make x in terms of u. So I'm going to take my equation here, and I'm going to solve for x. So when we solve for x, I'm going to add 1 to move it to the other side. So I have u plus 1 is equal to 2x. And then divide by 2 on both sides. So x is equal to u plus 1 over 2. So now I'm going to take this and substitute it into the x. So I have 1/2 on the outside of my integral. Now I'm going to plug in u plus 1 over 2 into the x, and then that's times the square root of u, which we don't really like writing the square root of u when we're doing our antiderivatives or derivatives. We like it when it's an exponent, so I'm going to change it to u to the 1/2 power du. Now this almost looks more complicated than what we started with, but we need to do a little bit more simplifying before we can take our antiderivative. So one thing that I could do is I can take out this 2 on the bottom. I'm going to put it on the outside. So when we divide by 2, it's like multiplying by 1/2. So I'm going to put another 1/2 on the outside. If I already have a 1/2 on the outside, what is it going to turn into? What's 1/2 times 1/2? 1/4, perfect. So that's going to turn into 1/4 when I take that out. And then I'm left with u plus 1 times u to the 1/2 power du. What do you think I could do to simplify this? So let's distribute. I'm going to distribute it to the 1 and the u. So when I have u times u to the 1/2 power, we add the exponents. My exponent on this u is a 1. So what does it turn into? U to the what power? What's 1 plus 1/2? 3/2, perfect. Plus 1 times u to the 1/2 power would just be u to the 1/2 power du. Now we can take the antiderivative here. So I'm going to leave that 1/4 on the outside. Don't forget to multiply it at the end. We'll just keep it out front. When we take our antiderivative, we're going to add 1 to the exponent. So this would be u to the 5/2 power times 2/5. Plus this would be u to the 3/2 power times 2/3. What am I missing? What do we need to include? Plus c, perfect. So then I'm going to distribute that 1/4. We don't really distribute it to c because c is just a constant. So we wouldn't call it 1/4 c because c is just a constant c. So 1/4 times 2/5 would be 1 over 10. U to the 5/2 power. Plus 1/4 times 2/3 would be 1 over 6 times u to the 3/2 power plus c. The very last thing we need to do is substitute the x's back into our u's. So we said that u was equal to 2x minus 1. So I'm going to plug in 2x minus 1 back into the u's here. So I have 1 over 10 times 2x minus 1 to the 5/2 power plus 1 over 6 times 2x minus 1 to the 3/2 power plus c. So this would be our answer. So if u and du don't fit exactly into your integral and you still have an x left over, you have to find what x is equal to. So you're going to use what u equals x. You're going to find what x is equal to in terms of u, substitute that in, and then simplify your equation, bless you, to something that you can take the derivative of, the antiderivative of. On the next page, we have guidelines for making change of variables. So we want to choose a substitution. So we're going to find what u equals. It's usually best to choose the inner part of a composite function. Then we want to find what du equals, which is going to be the derivative of u. We want to rewrite the integral in terms of the variable u. Then find the resulting integral, replace u by the g of x, or replace the u back with the x's, to obtain the antiderivative. And then you can check your answer by taking the derivative of your answer, and that'll give you the original question. Let's look at example 5. So what am I going to make u equal? X squared minus 1. Perfect. It's going to equal the inside. So u equals x squared minus 1. So then the derivative of u is going to be the derivative of that. So what's the derivative of x squared minus 1? 2x dx. So I'm going to plug u into the x squared minus 1. So this is going to turn into u. Then when I plug in du, we need a 2x dx. So I have an x and a dx. What am I missing? The 2. So I can put a 2 in there, but what do I have to do? I got to multiply the 1/2 also. Got to keep our balance here. So if I multiply by 2, I also have to multiply by 1/2. So now 2x dx is going to get substituted. The du is going to get substituted into that spot. So we have 1/2 times the integral of the square root of u times du, which we can change this to an exponent. So we have 1/2 times the integral of u to what power? To the 1/2 power du, and then we can take our antiderivative here. So don't forget that 1/2 on the outside. I'm going to add 1 to the exponent, so this is going to be u to the 3/2 power times 2 over 3. What am I missing? Plus c, perfect. Then we're going to distribute the 1/2. So 1/2 times 2/3 would be 1/3. U to the 3/2 power plus c. Again, we wouldn't call it 1/2 c, we just leave it as c because c is just any constant. And then we need to plug back in what u equals. So we're going to plug back in x squared minus 1 into the u. So I get 1/3 times x squared minus 1 to the 3/2 power plus c. And then to check our work, you could take the derivative of this. When we take the derivative, you'll end up with the original integral. So we know the power rule. That's what we've been doing the whole time. This is just power rule to take our antiderivative. Nothing special here. Let's look at A on the next page. So I'm going to say let u equal what? 3x minus 1, perfect. And then du is going to equal what? 3 dx. Don't forget the dx. So then when I substitute in, I have the integral of 3x minus 1 is going to change to u, and 3 dx is going to change to du. So I have u to the 4th power du. So then when I take the antiderivative here, we get u to the 5th power times 1/5. What am I missing? Plus c. Last step we have to do is substitute back in. So 1/5 times 3x minus 1 to the 5th power plus c. Let's do B. So what's u going to equal here? So if we let u equal 2x plus 1, and then we take the derivative of that for du, we don't have anything to plug into the x squared and the x. We could find what x equals in terms of u, but it would just make it more complicated. For your u, you typically want to make it the more complicated inside, because if you notice, if u is going to equal x squared plus x, what's du going to equal then? 2x plus 1, which would also take care of the other parentheses. So 2x plus 1 dx. Perfect. So let's substitute in. We have our integral of u times du. 2x plus 1 turned into u. And then, x squared plus x turned into u. 2x plus 1 times dx turned into du. So now we just have to take our antiderivative from here. So we have u to the second power divided by 2, or times 1/2, plus c. What's the last thing we want to do here? Plug in the u. So we have 1/2 times x squared plus x squared plus c. And if we took the derivative of this, we'd end up with our original question, our original integral. So let's look at example 6. Let's say u equals what? Awesome, x cubed minus 2. So then du equals what? 3x squared dx. So I'm going to say 3x minus 2, this one's going to equal u. So we're going to substitute our u into there. Then I have an x squared and a dx, but what am I missing? The 3. So I can put a 3 in there, but what else do I have to do? Put a 1/3 on the outside. Perfect. So we have 1/3 times our integral of the square root of u times du, which we could change this to be an exponent. So we have 1/3 times the integral of u to the 1/2 power du. So 1/3, our antiderivative of u to the 1/2 power would be u to the 3/2 power times 2/3 plus c. What would we do next? We can distribute the 1/3. So this would be 2/9 times u to the 3/2 power plus c. Again, we wouldn't put the 1/3 in front of the c because c is just our constant. And then what? We're going to plug in x cubed minus 2 into the u. So 2/9 times x cubed minus 2 to the 3/2 power plus c. So what do we want u to equal here? Awesome, 1 minus 2x squared. So then du is going to be the derivative of that. So what's our derivative of 1 minus 2x squared? Negative 4x dx. So I'm going to substitute u into the 1 minus 2x squared. And then I have an x and a dx, but I'm missing a negative 4. So if I multiply by negative 4 up top here, what else do I have to do? Awesome, I got to multiply by a negative 1/4 out front. So I have negative 1/4 times the integral of, this would be 1/u squared times du. Because that negative 4x dx just turns into du. I'm going to rewrite this to make it a little bit easier to take our antiderivative. So negative 1/4 times the integral of u to the power of negative 2 du. So I have negative 1/4 times, what's the antiderivative of u to the negative power of 2? Negative 1. So negative u to the power of negative 1. Plus c. What do we do next? Distribute. So negative 1/4 times negative 1 would be just positive 1/4 u to the power of negative 1 plus c. What would we do next? we can plug in 1 minus 2x squared. So we have 1/4 times 1 minus 2x squared to the power of -1 plus c. We don't really love negative exponents in our answer, so let's change this to be a positive exponent. So it would be 1/4 times 1 minus 2x squared plus c. So that would be our integral. If we took the derivative, we would end up with the original function. Like this one here, I would say let u equal x squared plus 1, but then du would have to equal 2x dx. And I don't have an x in there. I can't just put an x into my equation like I could just put a 2 into my equation. So we wouldn't be able to use our substitution here, but for a question like this one, how could we take the integral? What else could we do? We could just write it twice and FOIL it out. X squared plus 1 times x squared plus 1. When we FOIL, you'll end up with individual terms that we could just take the antiderivative of each term. So we wouldn't be able to use substitution in the one on the right like we would the one on the left, because the one on the left has that x in it. But we could just FOIL it out and take our antiderivative like we're used to.